So we've looked at what the difference is between an element, a mixture, and a compound. We know now that an element is a pure substance, which contains only one type of atom. A mixture can contain two or more types of atoms, and they're just mixed together, although they're not bonded. And then a compound has two or more types of atoms, two or more elements, and they have bonded together. They've undergone some kind of chemical reaction to make something new, to make a new substance. So because we've made a new substance, that thing that we've made is going to need a new name. We can't just call it all of the element names that were used to make it all joined together. We have to change something about it to show that it is a compound and not just a mixture, to show that something new has been made. So the names of any chemical compounds then are based on the elements that they are made up of. So we still use the element names, but we just have to change it slightly to show that what we have is a compound. So there are two main categories that I'm going to look at in this video. The first one is if we have two elements that have bonded together. So for example, I could have taken magnesium and reacted it with some oxygen. It's a very common reaction, and that we've probably just burned the magnesium in air and it's reacted with the oxygen in the air, in the atmosphere. Now what we've made then is something where magnesium has bonded to the oxygen. It's made a compound out of these two elements. But we can't just call it magnesium oxygen, because that doesn't show that a compound has been made. It doesn't show that a change has happened. So if we have two elements, what we do is we keep the first element the same and we change the name of the second element. How do we change it? We change the ending, which in this case is the GEN, and we change it to IDE, IDE. So what we've made when we react magnesium and oxygen is magnesium, first word doesn't change, oxide. And that shows that a bond has been made between these two because it's got the IDE ending. I know that it's a compound because it has that ending. Now, how did I know to choose magnesium first and not oxygen? Why is it not oxygen magnesite? The general rule to follow here is that if you have a metal reacting with a non-metal, then the metal is the first element. So the metal doesn't have its name changed at the end. It's the non-metal that gets the name change. Now that's fine for two elements, right? But what if we have three elements and one of them is oxygen? What we do here is again we change the ending, but we change it to 8 or 8. Now the difference between the two is actually dependent on how many oxygen atoms there are per molecule, but we're not going to worry about that just now. Just recognise that if you see 8 or 8 as an ending for a compound name, you know that it's not just two elements that have reacted together, there's also oxygen involved there too. So for example, if I had calcium, which is a metal, carbon, and oxygen, I don't call it calcium carbon oxide because that's too many words. I keep the metal name the same. Keep the carbon the same and use oxygen as ATE, 8. That lets me know that calcium has reacted with carbon, but oxygen was also involved because I see the ATE. Okay? So it's just important to recognise that and know that that means oxygen is involved here, as well as calcium and carbon. So there's 3 elements in total that went into making this compound. So just to do another quick example so that that's clear. If I had lithium sulfide, reading this, I know that lithium was involved, and the ending is IDE. So remember what that meant. That meant I've got 2 elements that have reacted, and the second element has had its name changed. So that means this is made from lithium and sulfur. Because it's got the IDE ending, it's only had 2 elements involved. If, though, it was lithium sulfite, that's the ITE ending, which is one of our 2 oxygen indicators. That means to make this compound, the element lithium has been used. Again, the element sulfur has been used. But there's also oxygen involved because it ends in ite or 8, depending on how many oxygens.